This is the quick estimation method for critical lane analysis. We're going to focus on 3 signalized intersections, and this is located in Raleigh, North Carolina. We've got 2 intersections with I40, the ramps for I40, and then another nearby signalized intersection. And this is Lake Wheeler Road, and Centennial Parkway is the road that connects with Lake Wheeler. And then again, this is I40. Here's our interstate. So what we're going to focus on with this quick estimation method is identifying movements and per lane volumes. That's the focus of the analysis that goes behind this. I'm not going to show all the details. I do have some other videos that show the details of this process. But essentially what we're looking to identify that peak 15-minute volume. We're going to take those volumes and multiply by 4 to get the hourly equivalent. And then we're going to need to divide all those volumes by adjustment factors. Those adjustment factors occur for those turning movements. So for right turns, we divide by 0.85. For left turns, by 0.95. And then finally, we're going to divide by the number of lanes to get per lane volumes. So the volumes that we'll look at when we're looking at actual movements will have gone through this process in the following slides. So we're going to start with the intersection of I40 eastbound ramps and Lake Wheeler Road. And this is not necessarily a traditional 4-leg signalized intersection because some movements are restricted. For instance, we shouldn't see left turning vehicles or right turning vehicles onto the exit ramp. Similarly, we shouldn't see vehicles in volume coming up the entrance ramp. So keep in mind this is a little bit different than traditional 4-leg intersection. In some ways it makes it a little more simple. Here are the actual volumes. This is a 2-hour time period, from 4 to 6 p.m., kind of that p.m. peak period in 15-minute increments. And we can see we're going to focus on, for the quick estimation method, the peak 15 minutes. There were 537 vehicles, and it was the time period from 5 to 5:15. And then again, remember, we're going to multiply that by 4 to get an hourly equivalent. We're going to divide by our adjustment factors, and those adjustment factors only applied to the left and the right turning vehicles. And then we're going to divide by the number of lanes to get a per lane volume. So the numbers I'm going to show in these following steps have had that applied to them, these 15-minute volumes. So we're going to start with the southbound left. So this is going to be its own phase of the intersection cycle, and there's only one volume there, so that's the maximum, or that's the critical movement for that approach, 345 vehicles per hour per lane. The next phase is going to be all the Lake Wheeler Road through and right movements. So looking northbound, 208 vehicles going through, 339 turning right. And then southbound, 420 vehicles going through. And so that's going to be obviously our highest volume of those 3. That's going to be our critical movement during this phase. And then from the exit ramp, 80 vehicles per hour per lane turning left, 235 turning right. And so the 235 is the larger of those 2. So that's our critical movement for that phase. And we're going to get our volume to capacity ratio 345 plus 420 plus 235 gives us 1,000 vehicles per hour per lane. We're going to divide that by our assumed capacity of 1,530. And that gives us a volume to capacity ratio of 0.65. So these volumes are roughly using 2/3 of the capacity of this intersection. Now we're at the intersection of Lake Wheeler Road and the I40 westbound ramps. So similarly to our previous ramp intersection, we shouldn't have volumes coming up the entrance ramp, and we also shouldn't have vehicles turning right or left onto the exit ramp. So keep in mind this is going to be somewhat of a more simplified intersection because some movements are limited. We're going to see zero traffic volume for these westbound ramps. On the eastbound side for the I40 westbound ramps, and that should be expected. Again, we shouldn't see volumes coming from the interstate up the entrance ramp. So that simplifies things for us. Our first phase, left turns, northbound left turns onto I40, only one volume moving during that phase, so 126 is our critical movement. Then we've got our Lake Wheeler throughs and rights, so 182 for the throughs, northbound 448 for the throughs southbound, and 315 for the southbound right turn, so 448 is the largest. And then finally our exit ramp, 295 for the throughs and rights, 118, I'm sorry, for the throughs and lefts, and then 118 for the rights. And the largest of that's obviously 295, so we're going to add those three together, 126 plus 448 plus 295. That's 869 vehicles per hour per lane, divided by our assumed capacity of 1,530. It gives us a volume to capacity ratio of 0.57, so just over half of the capacity of this intersection is being used by the current volumes during that peak 15-minute period. And finally, this is Centennial Parkway and Lake Wheeler Road intersection. There is the east side of the intersection is a gas station, so this similarly won't operate exactly like a traditional four-leg intersection because one of the approaches is a business, so we'll see lower volumes there, but every movement is represented in this four-leg intersection. Again, here are our volumes. We will see this westbound approach has pretty low volumes because it's those are the volumes coming out of the gas station here. So starting with our north and southbound left turns, that phase will go together, 194 on the northbound left, 21 on the southbound left. Clearly 194 is larger than 21, so that's our critical movement for that phase. Then on the throughs and rights for north and southbound, they're going to go in the same phase as well, 118 versus 300. 300 vehicles per hour per lane is clearly larger than 118, so that's going to be the value we use there. Then we have our approaches from Centennial Parkway, from the gas station 18 and 29 for the lefts and throughs rights, and then from Centennial Parkway 109 for the left and through, and then 715 for the right. So clearly that 715 is the largest. That's going to be the critical movement during that phase. So we're going to add those together, 194 plus 300 plus 715 gives us a total volume of 1,209 vehicles per hour per lane divided by the assumed capacity of 1,530. And at this point, you're using about 80% of the capacity of this intersection. So this is an example of how you would apply and how you would use that quick estimation method looking at critical lane analysis, looking at 3 different intersections that are closely aligned.